Hey there, Mr. Wilford here. I just want to go through Chapter 7, Section 3 with you, and this one's all about logarithmic functions. And you've probably heard of logarithms before or seen log on your calculator, log on your calculator. And so now we want to start to be able to investigate what logarithms are a little bit and figure out what they are and figure out how to use them and how to deal with them on your calculator and such. If you go back to the first two sections, we were talking about um, exponential functions. So we take a number to a power of x. And in the second section, we were talking about inverse functions. And what we're going to do is kind of tie them together now, trying to find the inverse of an exponential function involves a logarithm. So the inverse operation that undoes raising a base to an exponent is called finding the logarithm. A logarithm is the exponent to which a specified base is raised to obtain a given value. Um, you can write an exponential equation as a log equation and a log equation as an exponential equation. So part of the problems that you're going to look at in this section involve what we call the definition of logarithms. And it's really right here. And you want to actually be able to go back and forth with with these two equations. On the left side we have the exponential equation where we have our variable as a power. And then over here we have the log equation where this logarithm here is actually equal to x. And you can see here by the arrows that we're just kind of fitting everything in. It's kind of like a formula going from exponential to log side. You also want to be able to go in the other direction, go from the logarithm side to the exponential side. So a logarithm is an exponent, so the rules of exponents also will apply to logarithms, and we'll talk more about some different properties and things with logarithms as we go continue through the chapter here. But this thing here you want to write down, you want to have this in your notes somewhere. You're going to use that quite a bit the rest of the way here in this chapter. A logarithm with base 10 is called a common logarithm. If you don't see a base number there, a little subscript, then we assume it's base 10. So if no base is written, the base is to be assumed to be 10. So you won't see anything looking like this, log base 10 of 5. You will see it looking like this, right here, log 5. And we have to assume that it's base 10. You can use mental math and the definition of logarithms to evaluate some logarithms. So right here, if you have something like this, log of 1,000, what you're really asking is, again, this is base 10. 10 to what power will give you 1,000? Well, 10 to the third power will give you 1,000. So log of 1,000 is equal to 3. Log base 4 of 1/4. You're asking yourself, 4, the base, the little subscript is the base. 4 to what power is going to equal 1/4? Well, 4 to the negative 1 power is actually equal to 1/4. So this logarithm is equal to a negative 1. Now, be very careful. We'll talk more about this as we go, but base 10 logarithms, like this thing here, you can actually do on your calculator. Your calculator will only do base 10 calculations for logarithms. So if you plug in log 1,000 into your calculator, you should get 3. However, your calculator right now will not do log base 4 or other logarithms. It'll only do base 10, so be careful with that. That way you can kind of check your work. Because logarithms are inverses of exponents, the inverse of an exponential function, for example, y equals 2 to the power of x, is a log function, y equals log base 2 of x. So you could actually plug both of these into a graphing calculator and graph these two, and this is what it would look like. And if you remember when we talked about inverse functions, we said with inverse functions, they are a reflection across this y equals x line, this diagonal line. So you can see here again, this is my exponential function here, and this is my log equation there. If you have any questions with logarithms, please let me know. Thanks.